Hello viewers, welcome to interactive classes once again. I hope you have enjoyed the previous video on magnetism. If you haven't watched that video, you can find the link in the description box. Today we will start the second lecture on magnetism. Today we will learn two basic things of magnetism. The first one is very important, which is known as Maxwell's right hand thumb rule, and the second part is solenoid. So let's start the video today. Before coming to the fact, let me tell two important facts about magnetic fields. Magnetic fields are directly proportional to the amount of current flowing through the conductor. Magnetic fields are directly proportional to the amount of current flowing through the conductor. Number one. Number two is magnetic fields are proportional. Magnetic fields are proportional to the distance between the current carrying conductor and the point of observation. Okay, magnetic fields are proportional to the distance between the current carrying conductor and the point of observation. Now let me explain this fact. Suppose this is a current carrying conductor. I amount of current is flowing through this conductor. Okay, now let this be our point of observation. Let this point be our point of observation. So what happens is, if this distance suppose be x, so if the amount of magnetic field is flowing, okay, let me mark it as a point A. So if the amount of magnetic field flowing through this is B1, at this point the amount of magnetic field is B1. Now if again let this be another point C, and this distance from the conductor is greater than x, that is let this be x1 and this be x2, then the amount of magnetic field at this point C is B2, then B1 is greater than B2. That means if we increase this distance between the conductor and the point of observation, then the magnetic field decreases. Okay, and if the distance is less, the magnetic field is more. So that was all. Now let me explain Maxwell's right hand thumb rule. Maxwell's right hand thumb rule. What is the importance of Maxwell's right hand thumb rule? We know magnetic field has a direction and also magnitude. So if this is a conductor and current I is flowing through this conductor, it generates a magnetic field around it. So Maxwell's right hand thumb rule helps us to determine the direction of the magnetic field. Okay, so the basic concept of Maxwell's right hand thumb rule is, just hold your right hand and point the thumb like this, like a thumbs up. Okay, this thumb gives the direction of the current. Okay, and the other fingers, like this, the other fingers gives the direction of the magnetic field. Suppose current I is flowing through this direction, in the upward direction, then the curling of the fingers represent the direction of the magnetic field. Let me draw this now. Suppose this is a current carrying conductor I. Okay. Now, if we apply Maxwell's right hand thumb rule like this, so this is the direction of the current along the thumb, and the curling of the fingers represent the magnetic field around it. Okay, like this. So the magnetic field around this conductor will be like this, in this direction. This is a very simple law, but it's a very simple law, but this helps us to determine the direction of the magnetic field, and this is very important for your exams as well as for conceptual purposes. I hope this is clear. Now let me go to the next part. The next part is solenoid. So what is a solenoid? Let me write the description. What is a solenoid? The definition of solenoid is a coil of many circular turns of insulated copper wire wrapped closely in the shape of a cylinder is called a solenoid. A coil of many circular turns of insulated copper wire wrapped closely in the shape of a cylinder is called a solenoid. So how a solenoid looks? A solenoid looks like this. This is the direction of the current flow. Okay. The magnetic field lines are like this. This is the north pole because the current is flowing in this direction. So the field basically emerges from this part on the right hand side and ends in the south in the left part. That means this is the south pole and this is the north pole. There is a rule to determine the north pole and the south pole of a conductor or a magnetic field. Okay, we'll come to that part later. That is very easy. Okay, but for now we just determine it by the direction of the current. That is, the current is flowing in this direction. That means the field lines are along this direction. That means it starts from here. Okay, it starts from here and ends like this. That means, as we have discussed in the previous lecture, that field lines emerge from the north and end in the south. So this basically becomes the north pole and this basically becomes the second pole. So this is a solenoid. So what is the purpose of solenoid? A solenoid can be also called as an electromagnet. Okay, a solenoid is also an electromagnet which is used to magnetized materials such as ferrous, nickel, cobalt. So electromagnet basically is used to convert magnetic materials into magnet. What are magnetic materials? Magnetic materials are those materials which can be converted into magnet, like a piece of iron, for instance. So the derivation of the magnetic field expression is not in our syllabus for class 10 or so. Basically, this diagram and the definition is important for class 10 examinations. So we will not derive the expression of magnetic field here. So this is up to our syllabus. I hope you like the video. If you haven't watched our previous video on electricity, you can see it in the description box or in the playlist. I hope you like our video. If you like our video, please give a thumbs up, share and subscribe the channel. Thank you so much.